We'll practice finding the acceleration of a block on an incline with friction. Here's the problem. A 5.0 kilogram block is released on a 30-degree incline. The coefficient of kinetic friction between the block and the surface is 0.20. Using a free body diagram, determine the acceleration of the block down the incline. First, identify the forces along the incline. Take downslope as positive. The component of gravity along the incline is mg sine theta. Kinetic friction opposes motion, so it acts up the incline. Fk equals mu k times n, which is mu k mg cosine theta. Newton's second law along the incline gives ma equals mg sine theta minus mu k mg cosine theta. Cancel m and solve for a. A equals g times sine theta minus mu k cosine theta. Now substitute the given values. G equals 9.8 meters per second squared. Theta equals 30 degrees. Mu k equals 0.20. A equals 9.8 times sine 30 minus 0.20 cosine 30 equals 9.8 times 0.500 minus 0.20 times 0.866. A equals 9.8 times 0.500 minus 0.173 equals 9.8 times 0.327 equals 3.2 meters per second squared. The acceleration down an incline with friction is A equals g times sine theta minus mu k cosine theta